Hi, please look at page 141 to 143. Um, Previous session I explained about preparing soluble salt. Now I'm going to explain you about preparing insoluble salt. Insoluble salt, that means um, is related to those salts which are not able to be dissolved in a solution, water or any other solution. Making salt by precipitation is mainly divided two ways, two methods. Precipitation means formation of a solid like salt. Salt is a solid, okay, into a solution. It's a precipitation. So the two ways is when you mix two solutions together, that we are going to learn these pages by this method. This one, when a gas is bubbled into a solution. This is another way, but it's not mentioned in your book. So this slide shows you a general method when you have a phenol here, and if you put a hydrochloric acid, then add slowly to your solution like a calcium carbonate. Here there is, you can see at the bottom of the slide, there is a chemical equation for this test. If you have a calcium carbonate in your flask, which is called marble chips. Okay, marble chips is another name, is another structure of the calcium carbonate. So any acid like sulfuric acid, like hydrochloric acid, any acid, if you add slowly, like titration that I explained. Titration is different, but it's look like a titration. You need to add slowly hydrochloric acid to your calcium carbonate. Okay, then what is the products of these reaction is calcium sulfate, CaSO4, and water, and carbon dioxide. Carbon dioxide is a form of a gas. The form is a gas, and then can leave the flux through the pipe and can be collected in another in a gas jar. So there are 2 points. The reaction is strong, but after a while it quickly stops since calcium sulfate is insoluble. So when you prepare insoluble salt, once the insoluble salt, as an example here is calcium sulfate, they are not reactive with solution. Okay, the solution here is water. When you when once once calcium sulfate produce, then suddenly reaction stop, because cannot continue, because these marble chip are actually this one calcium sulfate, when will be produced, then cannot react with water anymore. Insoluble salts are generally made by ionic precipitation. So ionic precipitation, I will explain you more details about this reaction. So it's kind of replacement reaction. That means calcium here in calcium carbonate can be replaced by the hydrogen, and then will produce the calcium sulfate. The hydrogen can react with another two oxygen of the carbonate, and will produce the water, and the rest of one carbon and two oxygen from the carbonate will produce carbon dioxide. It's actually a replacement reaction, and the rest, which is not important, can be removed. We can simplify the reaction. There are many examples I put for this slide. For example, here preparation of a barium sulfate. Barium sulfate is another example of insoluble salt by ionic precipitation. So I said that the reaction is rely on ionic precipitation type. So for example, you have sodium sulfate here. Okay, sodium sulfate play a role of calcium carbonate like this. Okay, so here we have the hydrochloric acid, any acid like sulfuric acid, and here we have barium chloride. Barium chloride is another type of acid. So when we add slowly barium chloride to sodium sulfate, then you will get a precipitation of here barium sulfate. Okay, and then the rest, the solution is sodium chloride, and after a while the reaction suddenly stopped because barium, or the white precipitation barium sulfate, is not cannot continue the reaction anymore. So you can see the letter S means solid, is a solid, and a precipitation which is collected at the bottom of your dish. So yeah, if we simplify the reaction, you can see that only barium, okay, from the barium chloride react with here with sulfate, okay, SO3, then has produced the barium sulfate, which is solid and our precipitation. So this type of reaction is called ionic equation. We only consider the ionic involved with the reaction. The rest, like sodium, can be removed. This is actually, we are going to simplify the reaction and see which anion and cation are involved with the main product, because we are looking for the insoluble salt. Insoluble salt actually is a solid form, and it's a precipitation left at the bottom of the reaction. So here and the involved ions are called spectator ions. Here the involved ion are barium and the sulfate, and yeah, these two are spectator ions. Another example I put here, preparation of silver chloride. Silver chloride is insoluble salt, of course is a solid, and the color is white also. So by ionic precipitation, same is the same, but I'm giving you another example to see if we have any kind of acid to add another one, like here sodium chloride. Okay, sodium chloride and silver nitrate is our acid, and then we can get silver chloride, which is a precipitation. This is an arrow down, downward arrow is a sign for precipitation. That means you will get a precipitation or a solid insoluble salt at the bottom of your lab dish. And then sodium nitrate. Okay, this is another example, and here I simplified the reaction. It's the same example, these ones, silver chloride, and then the chemical equation is this one, sodium chloride and silver nitrate, and you will get silver chloride as your precipitation. This is your silver chloride is your salt, and sodium nitrate. If you separate, or actually if you convert the molecular structure to ionic structure, so it will be like this, a cation of sodium and an ion of uh, chloride, we learned before in previous chapters. So then after that you need to compare which ions are involved with your the final products, which is insoluble salt. Insoluble salt is this one, Ag, silver chloride, which is S. Okay, S means a solid precipitation. So then you need to find the corresponding reactants. The corresponding reactants is silver cation and chloride anion. Then the rest need to be removed. Then you can get the ionic equation. These are spectator ions which are involved with your reaction. So that's all for today. Please uh, leave a comment as done, and then I can see that you are presented for this session. Thank you so much. Stay safe at home. Thank you.